Hello and welcome, Mr. Lyons here. Hope all is well. And today we're solving systems of linear equations by what? Elimination. We were doing substitution. Now we're doing elimination. What does that mean, Mr. Lyons, elimination? Well, peep this scenario here, right? We have Jack and Jill buying candy, M&M's and Skittles. I can't stand Skittles, right? And we have equations here to show this, right? This is 3 plus 4, which is $7. What does the 3 represent? This is how much Jack spent on M&Ms. $4 is how much Jill spent on M&Ms, so that's $7 spent on M&Ms in total. $5 Jack spent on Skittles, $6 Jill spent on Skittles, it's $11 spent on Skittles in total. What does this bottom equation represent? This is Jack's total cost of M&Ms and Skittles. This is Jill's total cost of M&Ms and Skittles, which 18 is going to be the total cost of Jack and Jill's M&Ms and Skittles, right? Did you know that you can combine equations like this? Absolutely you can. There's a couple other ways you can do this. Let me show you another way you can write this equation. Right here we're adding Jack plus Jill to get the total. How about if I just do all of Jack's stuff, right? Let's do all of Jack's stuff right here. Let's say Jack, he spent $3 on M&Ms plus $5 on Skittles, which would give us what? $8 altogether. What about Jill? What would Jill look like, right? She spent not $3 on M&Ms, but she got $4 on M&Ms plus $6 worth of Skittles, which will give you $10 in total, right? And what happens? 3 and 4 is 7, plus 5 and 6 is 11, which gives you a total of 18, which also makes complete sense, right? What we're going to be doing today, and this is just a scenario, if you can come up with any more, that's completely cool. But what we're doing today, the main gist is you can combine equations. Let's take a look at example 1 here. Using the idea of adding equations from the problems above, right? Adding equations. Solve the system of linear equations below the same way. So when we solve systems of linear equations, what does that look like? What is our answer going to look like when we solve these? That's right, they're going to look like a coordinate point. And I'm going to annotate that in my answers down here. X comma Y, all right, just to get my answer ready down now. All right? So let's see, how can we add these equations together? First, organize your work. All right, we're going to add these equations together. What is 3x plus 2x? 5x. What is negative 5y plus 5y? That's right. You should notice here that you're getting opposites, which gives you 0. Negative 16 and positive 31 is going to give you what? Do that on your own. Don't wait for me. Do that. I did this already. Do this on your own. That's right. You should have gotten positive 15. Right? And now my 5x is isolated. Well, you know, shout out to Jay Sean who always says, that's 0. But we know 5x plus 0 is just going to be 5x. Right? So now I can isolate x. Now I'm going to isolate x. I'm going to do what? Divide by 5 on both sides. My x is going to be equal to positive 3. Right? That's the first step. Right? Notice how I'm organizing my work. Now that I have x, I can go ahead and find, that's right, I can find y. That's my next step. But it's like, which equation should we use? Well, I'm going to use the equation that has no negatives in it. So I'm going to choose the bottom equation. You can use the top and you should still get the same thing. If you want to try it out, go ahead and try the top and see if you get the same thing. But I'm going to use the bottom equation. Rewrite the original. Now I'm going to go ahead and substitute my x for 3. 6 plus 5. Pause the video and try it on your own. If you get to that point, you're like, I can do this. Try it on your own. Subtract 6 on both sides. 31 minus 25. Divide by 5. Divide by 5. Y is going to be equal to 5. So my answer should be 3 comma 5. However, what do? You got to make sure that you check. That's right. Right? And since I use the bottom one, I like to alternate. Since I use the bottom one, I'm not going to use the top equation to check. I have my x, I have my y. Let's see if it gives me a true statement, right? For x, I'm going to substitute 3. For y, I'm going to substitute 5. 3 times 3 is 9. Negative 5 times 5 is negative 25 equals negative 16. You can even use a commutative property here. Do this on your calculator if you need to. Negative 25 plus 9 is going to give you negative 16 equals negative 16. Booyakasha, look at that. So my answer is indeed 3, 5, because it satisfies both of these equations, okay? That check is really important as well. So now that we added and we combined these equations, go ahead and try example 2 on your own. The key will be on the next slide, but please try example 2 on your own. Use the notes that we just took to try it and annotate it on your own, right? Solve this on your own, and I'll see you in the next slide.